For today's lesson, we will be discussing about implicit differentiation. So this is another way of getting a derivative of a specific equation or function. So we will see how are we going to apply this one, the implicit differentiation, throughout this video. So first, let's compare what is the difference between explicit function and an implicit function. Okay, because you might be wondering what do you mean by implicit function or explicit function, because these two are two different things. So when we say explicit function, it is a function that is expressed in terms of x, or we can also think of it as in the form of y equals f of x. Okay, so it is expressed in this form. So that is what we call as explicit function. So what are examples of explicit function? So y equals 3x plus 4, we have y equals x squared plus 4x minus 2, we have y equals sine of 5x. Or in simpler terms, when we say explicit function, the terms with variable x are isolated on one side of the equation. And then we only have y here on the other side. Okay, so that is an explicit function. On the other hand, when we say implicit function, it is a function that is not written in form of y equals f of x. Or, if in explicit function, all the terms with variable x are isolated on one side, in implicit function, the terms with variable x and y may be combined, or both variables may exist on both sides of the equation. So examples will be this one. So we have 3x plus y equals 4, x squared plus y squared equals 9. We have 5x squared minus 3xy equals 4x plus y. So if you're going to compare the two, you will see in implicit function or equation, you will see that there are two variables existing on one side of the equation, or it can be like this on both sides. So there are times wherein you can just rearrange an implicit function. For example, this one right here. You can just move 3x on the other side so that it will become an explicit function. And if it's already explicit, then you can already get the derivative. Because remember, if we're getting the derivative, we get the derivative of a specific function in terms of x. But if it's like this, implicit function, we cannot just use the derivative rules that we studied. So there are times wherein the implicit function will be difficult, or it involves a lot of tasks before you can transform it into explicit function. That's why we have a specific rule in getting the derivative whenever we're dealing with implicit function, and that is what we call as implicit differentiation. So implicit differentiation is used to find the derivative, or dy over dx, derivative of y in terms of x, if y is an implicitly defined function of x. So remember this one, the dy over dx, that is just our y prime, or the derivative. So we use implicit differentiation if y is an implicitly defined function of x, or if you saw that the function given to you is implicit function. So implicit differentiation, it involves chain rule. So it uses the concept of chain rule in applying this one. But there are just two simple steps that we can follow if we want to use implicit differentiation. So the first step that we can do is to differentiate both sides of the equation with respect to x. So you just look at your terms, you get the derivative of all of the terms in your equation, both sides, with respect to x. So this is the additional step that we have to do. So when you differentiate a y term, or if you get the derivative of a term with variable y, then you have to multiply or attach dy over dx to it. Okay, so that's what we will do. So for example, I have to get the derivative with respect to x of 2y squared. Let's say this is the example. So we can just simply get the derivative of this using the differentiation rule. So just use the power rule here. That will be 4y And then, since the term here is a y term, or it involves a variable y, then we have to multiply it also with dy over dx, or you just have to attach dy over dx to it. And then that's it. So that's what we will do whenever you have to differentiate a y term. Next, after you're done differentiating all of the terms from your equation, you now have to isolate the dy over dx. What do you mean by isolate? You have to put all of the terms with dy over dx on one side of the equation. And we will manipulate that equation, and we should come up with dy over dx equals, and then whatever value we will get. Okay, so these are just the two simple steps that we have to follow. So do not forget, whenever you need or whenever you differentiate a y term, you have to multiply it also with dy over dx, or you attach this one. You will only do it if you differentiate a y term. So let's have an example. Find the derivative dy over dx if x squared plus y squared is equal to 4. So first thing that we have to do, we have to get the derivatives of all of the terms. So as you can see, this one is an implicit function because there are two variables present on one side. So what we will do is we have to get the derivative of our function with respect to x. So you just have to write it like this so that you know what to do for each term. Then after that, let's get the derivative. Since this one is just x squared, so I can just apply the rules that we know. So this will be 2x. No need to attach anything because this is just x. Next, we have y squared. So we have to get the derivative of this using also the rules that we know. So this will be 2y, but since this one is a y term, we have to attach dy over dx to it. Okay, and then this one, derivative of 4 is just 0. So now we're done getting the derivatives. Next thing that we have to do is to isolate the term dy over dx, or that means we only have to put dy over dx on one side of the equation and the other terms on one side. Since it's already here, we just have to move the 2x on the other side. So 2y dy over dx is equal to negative 2x. So we have here this one now. Next thing that we have to do is, since what we want is just this dy over dx, so what you can do is you can divide both sides of the equation with 2y so that we can cancel this one out, and we will be left with the dy over dx on the other side. And then here you just have to simplify this so you can cancel out 2. So you will be left with negative x over y, and then that's it. That is now the derivative of our function. So again, do not forget to put dy over dx whenever you are differentiating a term with y variable. Okay? Let's have another example. Find the derivative dy over dx if 4y cubed minus 2y squared plus 5y is equal to 8x squared minus 2. So we will do the same thing. Let's get the derivative of each term. So d over dx 4y cubed. Let's write it first like this, getting the derivatives in terms of x. d over dx 5y equals d over dx of 8x squared minus d over dx of 2. And then let's get the derivative of each. For this one, 4y cubed. So again, you can just simply apply the rule that we know. So power rule, you multiply it with 4 here and then subtract 1. So that is 12y squared. But again, since we get the derivative of a y term, so we have to attach dy over dx. Next, we have here 2y squared, so same explanation as this one, so that will be 4y, and then again attach a dy over dx since that is a y term. Next one, this is 5y, so the derivative of this is 5, and again attach a dy over dx since that is a y term. And then on the other side, we have here 8x squared, so that will be 16x. And then this one is minus 2, or the derivative of 2 is 0. So that is minus 0. So I will not put it anymore. Okay? Now, since after doing the derivatives, as you can see, all of the terms with dy over dx is already on one side. So we can now do the next step here. So we have to make sure that what will be left here on the right side or on the left side is just the dy over dx. But since there are three terms here and we cannot really combine them, you cannot subtract 12y squared with negative 4y or 4y. So what you will do is you can factor out the dy over dx because all of them has this term, the dy over dx. So you can just factor that one out, and then you have here 12y squared minus 4y plus 5 equals 16x. Because again, our goal is just to have this dy over dx on the left side. And then after that, like what we did in the first example, we will divide both sides of the equation with this one right here so that we can cancel it. 12y squared minus 4y plus 5. This one also 12y squared minus 4y plus 5. So cancel. Therefore, our final answer, dy over dx, is equal to, then you have the 16x over 12y squared minus 4y plus 5. And then that's it. That is now our final answer. It looks weird, yes, but just trust your solution. Okay, this one is correct. So if you can still simplify some of the terms here, then do it. But if not, then just leave it as like that. For our third example, so find the derivative dy over dx if we have x cubed plus 3xy squared minus 4x is equal to 5x squared y minus 12y. So again, let's write, get the derivative with respect to x of each term. So let's just write here 3xy squared minus 4, that should be d over dx. So let's write d over dx of 4x equals d over dx of the 5x squared y minus d over dx of 12y. Okay, now let's get the derivative of each. For the first one, this is just 3x squared. And then for the next one, okay, so look closely at the term 3xy squared. So if you will analyze this term, you cannot just simply say that the derivative of this is 6xy. Okay? So that is one of the mistakes that you might commit whenever you are doing implicit differentiation. You might forget some of the rules that we have to use whenever we're getting the derivatives. If you will look closely at 3xy squared, this is actually 3x times y squared. Okay, I don't know if you noticed that one, but 3x is multiplied to y squared. So that means there are two terms. We have u and v, and they are connected with multiplication. Then it only means we have to apply the product rule. So take note of that. You have to look at the terms and then analyze it carefully. Do I have to use another technique to get the derivative? Because again, the tendency is that you might overlook and you might not notice that you really have to use a product rule for this kind of example. So here, let's use the product rule. So I will be putting a parenthesis so that I know that I'm doing the derivative of this term right here. So remember the product rule, u dv plus v du. So u, so we have 3x times dv times the derivative of v, which is y squared. So the derivative of y squared, that is 2y. But again, since this is a y term, so we have to attach dy over dx plus v du. So we have v, which is y squared. Now, I'm not attaching dy over dx here since I did not differentiate the y squared. So you will only attach the dy over dx if you are getting the derivative of y term. Okay, so also remember that one. And then times du. So the derivative of that is 3. And then let's continue. This will be 4. The derivative of 4x is 4. And then here, we will be doing the same thing. So we have 5x squared times y. So think of it as like 5x squared multiplied to y. So there are again two terms being multiplied here. So let's apply again the product rule. So u, this will be our u, this is the v. So u dv. So derivative of v, derivative of y is 1, but we still have to attach the dy over dx, so that is just dy over dx. Plus v, then du, derivative of u, which is 10x. Okay? Minus, and then we have here 12y, derivative of that is 12, and then attach again the dy over dx, and then there you go, you already have the derivatives of each term. So next thing that we have to do now is to simplify this. So we will just simplify first the terms inside the parentheses. So I have 3x squared plus, this you can already multiply, so that is 6xy dy over dx plus 3y squared minus 4 equals, also this one, 5x squared dy over dx plus 10xy. And then minus 12 dy over dx. Now, next thing that you have to do is to isolate all of the terms with dy over dx. So here we have 6xy dy over dx, and then this one we move it on the other side, so that will be negative 5x squared dy over dx, and then this one as well, plus 12 dy over dx, and then the remaining terms we put it on the other side. So we have here 10xy, this 3x squared, this will become negative 3x squared, and then we have this 2, so that's negative 3y squared plus 4. Now, after you isolate all of the terms, the next thing that we have to do is to factor out the dy over dx, so that we can cancel out later on or divide our fraction. So we have to isolate the dy over dx. So what will be left is 6xy, and then minus 5x squared plus 12. Minus 5x squared plus 12. There you go. And then copy the other side, 10xy minus 3x squared minus 3y squared plus 4. So there. So after you factor out, of course, we will divide. So divide both sides now by this one. So 6xy minus 5x squared plus 12. 6xy minus 5x squared plus 12. So this will be cancelled. So you will be left with this term, 10xy minus 3x squared minus 3y squared plus 4 all over 6xy minus 5x squared plus 12. Again, if you can still simplify some of the terms, go ahead, but if not, then leave it as like that. That will be our final answer already. And for our last example, find the slope of the tangent line to the curve 4x squared plus 9y squared minus 6xy plus 5x minus y minus 60 equals 0 at 2, 3. Okay, so since we're trying to find the slope of a tangent to a given curve, so remember our discussion about the tangent lines and normal lines. We can identify the slope of the tangent line by getting the derivative of our function or the derivative of the curve, and also after getting the derivative, we evaluate it by the given point. So that is what we will do here as well. Since we have the curve and we have to find the tangent, so what we need to do is just to find the derivative of this curve and then evaluate it later on using the point 2, 3. So let's do it now. Derivative, since this one is an implicit function, so we have to do implicit differentiation. So you get the derivative of each term. So like this. Then plus d over dx of 5x minus d over dx of y minus d over dx of 60 equals 0. Then this one is just 0, so I will not put dy over dx here, or d over dx here, because that will just be 0. Okay, let's get the derivative of each. This one is 8x plus, and then we have here 9y squared. So we have to get a derivative of this, which will be 18y, and then since this is a y term, we have to attach dy over dx minus, then here we have the 6xy. So same as with our example a while ago, this involves two terms, the 6x and y. So 6x is multiplied to y. So we can look at it like that and use the product rule. So this is our u, this is our v. So again, I'm putting a parenthesis here. So apply the product rule, u dv, u times the derivative of v. Our v is y, so its derivative is 1, but we have to write dy over dx plus v du, so v is y, times du, which is 6. Okay, and then continue the rest of the terms, plus, and then this one is 5 minus, here we have y, so get the derivative of that, that will be 1 with the dy over dx, so that is just dy over dx. Then minus 0 equal to 0. Now next thing that we have to do is to simplify first the one inside the parentheses. So 8x plus, then we have 18y dy over dx minus, and then since this is minus, so we also have to distribute, because the one that is negative here is the whole derivative of 6xy. So I have to distribute this to the two terms here. So this will be negative 6x dy over dx, and then this one will be negative 6y plus, oh no, let's remove that one, plus 5 minus dy over dx equal to 0. Now, next thing that we have to do is to isolate all of the terms with dy over dx. So, all of the terms are on one side, so we just have to move or transfer those terms without the dy over dx on the other side. So, we have here 18y dy over dx minus 6x dy over dx, and then the minus dy over dx equals, then we have the negative 8x plus 6y minus 5. And of course, the next thing that we have to do is to factor out the dy over dx. So let's factor out the dy over dx, dy over dx. So we have here 18y minus 6x, and then this one minus 1, so minus 1 equals, and then let's just copy this negative 8x plus 6y, negative 8x plus 6y minus 5. And then what we will do is we will divide both sides by this one, 18y minus 6x minus 1. So just divide. So cancel. So we have now dy over dx is equal to negative 8x plus 6y minus 5 all over 18y minus 6x minus 1. Now, after getting the derivative, since what we need is the slope, we have to evaluate the derivative using the given point. Last time, we only used x because the only variable present is x. But since we already have here the y variable as well, so we will be using both of the values. So let's substitute. So negative 8 times x, which is 2, plus 6 times y, which is 3, minus 5 all over, then we have 18 times y, which is 3, minus 6 times 3, and then minus 1. So just simplify everything. So we should get negative 3 over 41. So this is now the slope of our tangent line. By the way, this one right here should be 2. Because that is x. Because that is x. So let's write here 2. Okay. There. So remember, if you want to get the slope of a tangent line to a certain curve, you just have to get the derivative first and then evaluate. So that's it for today. I hope you learned something about implicit differentiation, also how to determine an implicit function, and see you next time.